Here is a straight line, RS. From what we said last time, what do I know about the line or about its gradient? Well, sloping up from left to right, so we could say that the gradient is positive. If I knew the coordinates of R and S, I could say, oh, okay, I'll work out the gradient by doing change in Y for change in X. If I wanted to know the angle that this line makes with the horizontal, I could say, well, that's tan theta equals the gradient. If I can get the gradient, I could work that out. But that's really as much as I can say at the moment. But here's another line, this line ST. Now, if I was to tell you that RS is parallel to ST, so in a diagram, all right, that would normally be marked, a little arrow here, another one on here. Then we say, how do I know that they're parallel? How can I prove they're parallel? Well, if I work at the gradient of RS and the gradient of ST, if the gradients are the same, they must be parallel. Oh, but I've got point S and a point S. I can't have 2 points S. I'm telling you now that this point S on the first line and the point S on the second line is the same point. So in other words, this second line should slide down to make point S go inside there. Oh, well, now we've got a condition that we've got the lines parallel, R to S, S to T, but S is the point in common. Then we can say that R, S, and T are on the same straight line. And the fancy word for that is collinear. So conclusion here, collinearity. Lines which have the same gradient are parallel, and if as well as being parallel, they also have the same point in common. That's crucial. They must state both things. For exam board purposes, we must understand both are true. If they're parallel and have a point in common, then we can say they are collinear, which means that they lie on the same straight line. For the spelling, by the way, it's always double L and one N. There will be some of you who always write it the other way around. Okay, so in our notes, we're now on to page 5, collinearity. All right, this one here. So if I've got some points like here, all right, points P, Q, and R, all right, then we've just been saying if two lines are parallel and they have a point in common, then we can say they're collinear. So for example, are A, B, and C in this example collinear? All right, gradient of AB, all right, change in Y over change in X, 3 take away 1, 1 take away minus 2, so I'm using this as 0.2 and this is 0.1, the gradient is 2 over 3. If I do the same for gradient of BC, so now for BC, I'm going to take this as 0.2, and this is 0.1, okay? Then I'm going to have, say, that's, all right, my change in Y, 7 take away 3, change in X, 7 minus 1. What can I say? All right, gradient of BC is 4 over 6, which simplifies to 2 over 3. Okay, now if at this point the two gradients were not the same, then I would say the lines are not parallel, so they are not collinear. However, I can say here, gradient of AB does equal BC, all right? Therefore, they are parallel, and I must state this for the exam board. And then I can't just go from there saying they are parallel, therefore they're collinear. No, they are parallel, plus they have a point in common, all right? And it's point B, because I worked out gradient of AB and gradient of BC. So we'd say, therefore, they are parallel, plus they have point B in common. So I state that, they have point B in common. You must write this in the higher exam if it comes up. Therefore, because they're parallel and because they have a point in common, I can now say they are collinear. Okay? So these points here in my sketch, I just said roughly where they are, not necessarily collinear at this point until I've done the calculation. They're parallel and they have point B in common, therefore they're collinear. Please note once again, please put in the origin and your label your X and Y axes. All right, that's half the topic today. All right, second topic, perpendicular lines. Perpendicular, all right, fancy maths word meaning at 90 degrees. So perpendicular lines, lines which meet or cross at 90 degrees. What can we say about perpendicular lines here? All right, well, this is gradient 1, so M1, and if this is gradient M2, it's a mathematical fact that if two lines are perpendicular, then the gradient of the first multiplied by the gradient of the second must be -1. Please fill this in your notes as well as the example. This is a crucial higher mathematical rule for straight lines. Perpendicular lines, right? The product, all right, that means if I multiply the gradients together, then I must get -1. All right, the explanation on here. So here's the fancy bit if you want to put it down somewhere on the back of your notes. Perpendicular lines, there it is stated, right? Two lines are perpendicular if and only if the product of their gradients is -1. That means if I'm told they're perpendicular, then I know that the two gradients must multiply to be -1, and also the other way around. If I happen to be looking at two lines and I say, oh, when I multiply the gradients I get -1, then I can say, therefore I know they're perpendicular. All right, so it works both ways. Things don't always work both ways. If I say that creature is a dog, a normal healthy looking dog, presumably it's got 4 legs and a set of teeth. If I look at a creature and say it's healthy looking and it's got 4 legs and a set of teeth, doesn't necessarily follow it's a dog. Could be a cat, could be a severely deformed chicken, we just don't know. But this rule does work both ways around for perpendicular lines. Here's how it works. Right, jot these examples down, please. Okay. All right, the question says, give the gradients perpendicular to, and there's 4 wee examples here, 3/2 for the first one. Second one, what's perpendicular to a line with gradient -5/4. The third instance, what's the gradient perpendicular to a gradient of 6. And lastly, perpendicular to -1/8. Here's how it goes. Here, first of all, I will show you the official way of setting it out. We must set down, first of all, the rule that we're using. The rule is that M1 times M2, you can put in a multiply sign if you wish, don't need to, all right, is -1. Put that in each time you do one of these questions. Shows the rule. Basically, this counts as you're working. Okay, so I know the first gradient, I was trying to work out M1, the first gradient is 3/2, and I'm trying to work out M2. So I can say, okay, 3/2 multiplied by my second gradient must be -1. Okay, so, all right, so M2 is -1 divided by 3/2 to undo the multiplying process, which is -1 times divide by a fraction, multiply by the inverse, turn it the other way up, equals, -2/3. All right, now if you're unsure, but you had the rules, then that's the way of doing it. Okay, but please note, I started off, first gradient is 3/2. My last gradient, my second gradient, was -2/3. Same figures, swapped the other way up, and changed the sign. That always works when you divide to get two gradients to multiply to be -1. All right. So, to recap, that's the recap. Maths geek joke there. All right. We don't need that step, or that step, or that step. You can write them down if you wish, but there's no need. So long as you write down M1, M2 is -1, you can cut straight to the answer. So my second gradient must be invert the figures, swap the sign. So, for example B, I will put my working. M1, M2 is -1. My second gradient is, swap it the other way up, 4/5. Change the sign, minus becomes positive, 4/5. Done. But what if they tell me the first gradient is 6? Write down the rule. 6 is a fraction. All right? Doesn't look like 1. Say, oh, it's a whole number. Yes, but 6 is, as a fraction is simply 6 over 1. So I can say m2, swap it the other way up, minus 1 over 6. And of course that makes sense. If you think about it, to go back to the first principles of what we're doing here, all right, why did that work? Because if I say m1, m2 is minus 1, oh, and the first number is 6, so 6m2 is negative 1. Oh, we'll divide both sides by 6, m2 negative 1 over 6. All right. So it works both ways. All right. When you know the shortcut way, don't forget where it comes from. And finally, in the same way then, we've got 1 gradient of minus 1 over 8. Write down the rule. What do I say? Oh, so m2, turn it the other way up and swap the sign. Minus 1 over 8 becomes 8 over 1. Oh, but I don't need to write that because 8 over 1 is simply 8. So I've got my second gradient. Okay. Again, suggest you write these down for yourself, try them out, and check the video again if you go. To complete the notes, how do we use this? Exam questions. Well, here we go on page 5. All right. 2 gradients. All right. Gradient L1 times the gradient of L2. Well, if they're perpendicular, I know I must multiply 2 minus 1. So my gradient of L2, take the figures, right, as regards the exam board, etc. All they require, turn the numbers the other way up, swap the sign. It's done. Oh, that things were going to be that easy in the exam. But no, let's look at one that was more likely. All right, so here's the question. All right, it's triangle ABC. Now I've only written in AB and BC. All right, of vertices. Now I've done a little sketch. Show it's a right-angled triangle. Now, this is not necessarily right angle, but I can see from here, I mean, I can put in that line if I wish. But if it is going to be right-angled from the sketch, all right, by plotting the points, not accurately, not hyper-accurately, but I can say, well, if that's 0, 6, 4, 8 roughly up there, 6, 4 roughly down here, if it's right-angled anywhere, it's going to be here. So let's check it out. I work out the gradient of AB. Gradient of AB, change in y over change in x, works out to be a half. In the same way, gradient of BC, well, you can see it's going down, so it's definitely going to be negative. All right, change in y over change in x. This time, just for the sake of it, I said I'll do this as 0.2, this is 0.1, so 8 take away 4, 4 take away negative 6. Doesn't matter which way around, as we said previously. It's 4 over negative 2, which is negative 2. We're not done here. And when you give your justification, which you have to put at the end, please don't say something like, I know they are perpendicular because if you take one and swap it the other way up and change the sign. All right? That is not mathematical speak at all. What are we doing? We're looking at what happens when we multiply the 2 gradients. We wanted to find out what the product is. So I say, I've worked out the first gradient. I've worked out the second gradient. I will now multiply my 2 gradients together. So this shows what I'm doing. Gradient AB times gradient BC. There's my first gradient. There's my second gradient. So I'm substituting in a half multiplied by negative 2, which is negative 1, which doesn't surprise me because they wouldn't have asked the question if that wasn't going to happen. Right. Oh, equals negative 1. So this is one of these things about doing it the other way around. I've shown that the product of the 2 gradients is negative 1. So I can say, therefore, angle ABC is a right angle. So the triangle is right angled. And so the question is done.